Hyper-V is a Type 1 hypervisor developed by Microsoft to enable hardware virtualization. As a Type 1 hypervisor, Hyper-V runs directly on the physical hardware rather than on top of an operating system, which differentiates it from Type 2 hypervisors. The architecture of Hyper-V is designed to manage and allocate physical resources to virtual machines efficiently while maintaining isolation between them. The host OS is the physical machine's operating system, which runs the hypervisor. In the case of Hyper-V, this host OS is typically Windows Server or Windows 10, 11 Pro, Enterprise, or Education editions for client-based installations. The host OS performs administrative functions and runs applications, services, and management tools that interact with the virtualized environment. Key components in the host OS include the Hyper-V hypervisor, which is the core component of the architecture, the parent partition, which is the first and primary virtual machine that runs on Hyper-V, and management tools like Hyper-V Manager, PowerShell, and System Center Virtual Machine Manager that administrators use to configure, manage, and monitor the virtual machines. The Hyper-V hypervisor is a critical component that sits between the hardware and the virtual machines. It provides the low-level virtualization capabilities that allow the creation and management of VMs, enabling them to share the host's hardware resources. Key functions of the hypervisor include resource allocation, isolation, scheduling and execution, and virtual device emulation. Key components of the hypervisor layer include the virtual machine monitor, which controls and manages the execution of virtual machines, and virtualization extensions like Intel VTX and AMDV that assist the hypervisor in managing virtualization. Each virtual machine in Hyper-V runs in its own child partition, which is a virtualized environment running on top of the hypervisor. These child partitions are isolated from each other, meaning they can run different operating systems and applications without interfering with the host or other VMs. Key characteristics of virtual machines include guest operating systems, virtual hardware, isolation, and dynamic resource allocation. Hyper-V provides a virtual switch to manage networking between the host, virtual machines, and the outside world. The virtual switch acts as a virtual network hub that can be configured to provide different networking setups. Types of virtual switches include external virtual switch, which allows VMs to connect to the external network, internal virtual switch, which allows communication between the host and the VMs, and private virtual switch, which allows communication only between VMs on the same host. Each virtual machine in Hyper-V requires a virtual hard disk, which is a file that simulates a physical hard drive. The virtual hard disk stores the operating system, applications, and data for the virtual machine. Key features of VHD/VHDX include VHD, the older format for virtual disks, and VHDX, the newer format that supports larger disk sizes and additional features. Hyper-V supports dynamically expanding virtual disks, where the VHD/VHDX file grows as data is written. Hyper-V provides integration services to improve the interaction between the host and the guest operating systems running on virtual machines. These are drivers and services installed in the guest OS that enhance the VM's performance and enable features such as time synchronization, heartbeat monitoring, shutdown integration, VSS support for backup, and mouse integration. Integration services are automatically installed when the guest OS is a supported version of Windows. While for Linux-based OSs, the Hyper-V Linux integration services need to be installed manually. Hyper-V manages virtual storage for virtual machines through virtual hard disks and virtual storage controllers. The storage resources for VMs can come from local storage, SANs, or network-attached storage. Hyper-V supports several storage options, including fixed VHD, VHDX, dynamic VHD, VHDX, and differencing VHD, VHDX. Hyper-V also supports live migration of virtual machines to different storage locations and virtual disk sharing for high availability and disaster recovery scenarios. Management tools for Hyper-V include Hyper-V Manager, a graphical interface for managing Hyper-V, PowerShell, a powerful scripting interface for automation, System Center Virtual Machine Manager for centralized management, and remote server administration tools for remote management. In summary, Hyper-V's architecture is designed to provide efficient and scalable virtualization solutions, with a clear separation between the host system and the virtual machines running on it. The key components include the hypervisor layer, virtual machines, virtual networking, and storage management, all controlled by powerful management tools. This modular and flexible architecture allows Hyper-V to scale from small deployments to large enterprise environments with multiple VMs, ensuring high performance, isolation, and manageability.